weighing 64 pounds stretches 0.32 foot. The mass is initially released from a point 8 inches above the equilibrium position with a downward. So the question asks to find the equation of the motion. Okay, firstly, to find the equation of the motion, you need to know the differential equation for this case. So the differential equation for this case is md b squared x over dt squared plus kx equal to 0. So we need to find the value of m and k. So in order to find the value m is mass. So if we want to know the mass is weight over gravity. So weight given from the question 64 pounds equal to 64 pounds over 32, we will get 2. Okay, to know the value of k is equal to mg over s. So m is, we know from this m is 2, g is 32, so 2 multiplied by 32 divided by 0.22, we will get 200. So we substitute the value of m and k into the dE. So we substitute it. So we will get 2 d squared x over dt plus 200x equal to 0. So from this dE, we can simplify it. We will get d squared x over dt plus 100x equal to 0. Okay, the general solution for this case is x equal to c1 cos wt plus c2 sin wt. So if we want to know the general solution, we need to know the c1, w, c2 and w. So to find the w, we need to reconstruct the auxiliary equation m squared plus w squared. We get this from the dE. Since this is the second order, so the, m will be m squared plus w squared equal to 0. So w squared we get from this. W squared is equal to 100. Then we want to know the value of w. Then we square root it, we will get 10. W is equal to 10. So we substitute the value of w into this general solution. We will get x equal to c1 cos 10t plus c2 sin 10t. So now we need to know the c1 and c2. Okay, to find the c1 and c2, from the question there is stated that the mass is initially released from a point 8 inch above the equilibrium position with a downward. So from this statement, we will get 2 IVP, which is x 0 equal to minus 2 over 3 and x 0 equal to 5. So first we use this IVP, then we substitute it in this equation. So the value of t is 0, so we substitute it. Then the value of x is negative 2 over 3. So when we calculate it, we will get c1 equal to negative 2 over 3. Next, for the second IVP, we just substitute it just like this. So the value of x is 5 and the value of t is 0, so we substitute it. So we will get 5 equal to 10 C2. So we want to know the C2, so we just divide it. So we will get C2 equal to 1 over 2. So we since we get C1 and C2, we just plug in the value into this equation. So we will get x equal to negative 2 over 3 cos 10t plus 1 over 2 sin 10t. Okay, so we get the equation of the motion, but we can write the equation in the form of x equal to a sin wt plus b. Okay, to write in this form, we need to find a and b. Since we w we just get from this equation. So we need to find the value of A and field. To find the value of A, the value of A is the square root of C1 squared plus C2 squared. Okay. For the field, the equation is tan field over C1 over C2. So to find the value of A, we just plug in the value of C1 and C2. So C1 is negative 2 over 3 and C2 is 1 over 2. So we calculate it, we will get 5 over 6. Okay, for field, tan field equal to C1 over C2. So C1 is negative 2 over 3 divided by C2, which is 1 over 2. So we will get field is negative 0.927. So now we have value of A and value of field. So we can just plug in into this equation. So the equation of this motion is x equal to 5 over 6 sine tan t minus 0.927.
Hi, I'm Roshamira. I want to explain on question number 2b, Roman 1. So the question wants us to find the charge on the capacitor in an LRC series circuit at t equal to 0.01 second when L equal to 0.05 H, R equal to 2 ohm and C equal to 0.01 F and ET equal to 0 volt. Given that Q 0 equal to 5C and I0 equal to 0A. So this is the formula given, and so this is the given by the question, and first we need to substitute the value into the formula. So we do like this, and until we got the general equation. Next, to find the auxiliary equation, we do m squared plus 40m plus 2000 equal to 0, and we got m1 like this and m2 like this. So this is the auxiliary equation, and C1 and C2 as a constant. So we have been given Q0 equal to 5, so C1 is equal to 5. Then from QT, we differentiate QT and we got like this, all of this. Since I0 equal to 0 and it also equal to Q prime 0, then negative 20 C1 plus 40 C2 equal to 0, and it is first equation. And to find C2, we do like this until we get 5 over 2. Therefore, QT is equal to this. Next, to find the charge on the capacitor in an LRC series circuit at time equal to 0.01 second. So we just substitute T into this equation. We solve all of this until we got the value 4.5676 C. Now, to find the first time at which the charge on the capacitor is equal to 0. So from this equation, we do like this. So 5 over 2, we move to the left. We got like this. And we know that sin over cos equal to tangent. Then we solve until we get the answer. Next, also arctangent is defined within negative 90 degree to 90 degree. We have to seek the answer in between 90 degree to 180 degree. So we need to add by pi. So we solve until we get this answer. So the time is 0.050.
Question to Roman 2 is find the steady state charge and the steady state current in an LRC circuit when L is equal to 1 hour, R equal to 2 ohm, C equal to 0.25 F, and ET equal to 50 cos t. So before we find the answer, we need to come up with the differential equation, which is LQ double prime plus RQ prime plus 1 over CQ equal to ET. So we need to substitute the values from the equation to the differential equation. After we get the differential equation, we need to find the auxiliary equation. So from the auxiliary equation, we need to solve the M. So from the M, we obtain the values of gamma and beta, which is we can find the equation of YC. So next, we need to find YP. To find the values of A and B, we need to differentiate the equation of Y to first derivative and second derivative. After that, we need these three equations need to be substituted into the original differential equation. So lastly, we got the value of B, which is 100 over 13, and the value of A is 150 over 13. So,
okay, for the question number 2, Roman 3, we need to find the steady state charge and the steady state current in a LRC series circuit when the impulse voltage is ET equal to E naught sin gamma t by Kirchhoff's second law. L di over dt plus Ri plus 1 over Cq equal to Et. Then the voltage and the current relationship in circuit analysis is I equal to dq over dt. So we substitute this in Kirchhoff's second law. So we get this, and we let L equal to LH, R equal to R ohm, and C equal to CF, and lastly is Et equal to E naught sin gamma t to the equation this. So we got this, and after that we need to find the value of M by in auxiliary equation. So auxiliary equation is M squared plus R over Lm plus L over C equal to 0. After that, by alpha and beta we got M, which is negative 2 plus minus 3i. So we got the equation of QC, which is E negative 2R over L T bracket C1 cos 2L, and so by using the method of undetermined coefficient, we assume a particular solution of the form. So our undetermined coefficient is QP equal to A cos gamma t plus B sin gamma t. We differentiate, we got this, and differentiate again, we got a negative gamma square A cos gamma t minus gamma square plus B sin gamma t. So we let this as equation number 1. We substitute second derivative and first derivative and Q in the equation 1 to find A and B. By compare the equation, for the part 1, we compare the cos coefficient, which is negative gamma square LA cos gamma t plus gamma RB cos gamma t plus 1 over C A cos gamma t equal to 0, and we got B, which is negative A plus gamma square LCA over gamma RC. We led by equation number 2. For part 2, we compare about sign. So negative gamma square LB sin gamma t minus R gamma A sin gamma t plus 1 over CB sin gamma t equal to E naught sin gamma t. So after we simplify, and we got the equation for A, which is E naught gamma RC square over 2 gamma square LC minus Y 4L2C2 minus gamma 2R2C2 minus 1. So we let it as equation number 4. So from the equation previously, which is equation 2, B equal to negative A plus gamma square LCA over gamma RC, and we simplify as B equal to A bracket gamma square LC minus 1 over gamma RC. We let at equation 5. After that, substitute equation 4 in 5. We got this, and we let as equation number 6. So after that, from the previous equation, let x equal to gamma L minus 1 over gamma C. So, and then y equal to negative 2L over C plus gamma square L2 plus 1 over gamma 2C square. Next, by substitute x and y into equation 6, we got B equal to E naught x over negative gamma in bracket y plus r square. So we let it as equation 7. And also substitute y into equation 4. A equal to E naught r negative gamma in bracket y plus r square. We let it equation 8. Just substitute equation 7 and add into the this equation, which is QP T equal to A cos gamma T plus B sin gamma T. After we substitute, we got this QT. So the steady state charge is QPT equal to in bracket E naught R over negative gamma in bracket y plus r square cos gamma T negative E naught x over gamma in bracket y plus r square sin gamma T. Now the steady state current is given by Q prime P equal to IP. Then Q prime P is negative gamma E naught R over negative gamma in bracket y plus r square sin gamma T minus in bracket y E naught x over gamma in bracket y plus r square cos gamma T. So this is our, after we simplify, we got this is our Q prime P. So the steady state current is IPT equal to E naught R over y plus r square sin gamma T minus E naught x over y plus r square cos gamma T.
Turning this on, going on, going